We're asked to draw the region bounded by these curves. So it's y equals x plus 3, y equals x plus 7. So they're parallel. One has a y-intercept of 3 and one has a y-intercept of 7. So one just above the other. X equals 0 is this vertical line right here, and then x equals 6 is another vertical line. So that's the region bound by those curves. So you really want to look at the y-intercepts if it's multiple choice for picking the right region. And then the washer method works by thinking of a right cylinder that you're taking, and when it's rotated around the x-axis, so it's a cylinder that's going this way. They want to take the bigger cylinder and subtract it by the smaller cylinder. So this cylinder here, it just has a height that's infinitely small. I'll draw a height that's not infinitely small just so we can see it. Right, so it's like we're taking little pennies to help us find the volume, except the pennies are getting infinitely small in their width. So if we're to find a formula for this right cylinder that's coming down this way, the radius is dictated by the y value of the higher line, right? So the radius of that cylinder is the y value. It's x plus 7. And so the volume of that cylinder, it's pi x plus 7 squared times the height, which is dx. Right? It's an infinitesimally small slice that we're taking out of this. This is the volume for one infinitely small slice of the bigger, the function that's higher on the y-axis. And then we just do the same thing for the smaller one. Here, I can't get rid of that. Because the next one we're doing, this isn't an infinitely small one, but just so we can draw it so we can actually see it. This is another right cylinder, but it's being determined by this x plus 3 line. So that one's going to be pi, same type of r, it's coming from the y value, pi r squared h. So the washer method is where you integrate from the starting point on this, in this case, the x-axis, to the ending point in the x-axis. And it's pi r squared minus pi r, different r squared dx. So we can factor out the pi. And then I'm going to expand both these parentheses. X plus 7 times x plus 7 gives us x squared plus 14x plus 49. And then we're subtracting that by x squared plus 6x plus 9. So if we combine terms, x squared minus x squared makes nothing. 14x minus 6x makes 8x. And then 49 subtracted by 9 makes 40. And now we can find the antiderivative. And then evaluate it for our limits of integration. So 6 squared is 36. 36 times 4 is 144. And 40 times 6 is 240. So we add those together. We got 384 pi.